I think I might die of starvation. So I'm going to record this lecture and then I'm going to go to the store so that I can survive the day. I need to eat. So, anyway, all joking aside, this is a great lecture. I'm going to try to keep it short and simple, but this really is where the rubber meets the road. I love this. I love this discussion. Okay, so we are going to estimate costs using the scatter diagram, the high-low method, and regression. Before I get into the detail of the discussion, I sort of want to just kind of sketch something out, right? I have a line, okay? This is my total cost. It's supposed to be a straight line. It's not the best straight line, but as straight as I can draw. I'm a terrible drawer. But anyway, I have a straight line, okay? And what I want to do is I want to say, hey, if my sales were way out here, right? So if I were to extend things, God, I am the worst fucking drawer. Yeah, so here's the deal. I don't really care if I swear. If I'm swearing in these things, I'm totally fine with that because that really is who I am. But it's the word like. I'm trying to get rid of that word from my vocabulary. So, swearing is okay. Using the word like, not okay. But what I'm trying to get at in this particular lecture is let's say that I have uh, volume, okay, and this is the line is what I have been doing. And what I'm saying is that based on where I've been in the past, right? I'm somewhere on this line. And next period, I am estimating that my volume is going to be out here. And so what I want to know is next period, what are my costs going to be given this volume? And so what we're going to do, don't freak out, but we're really going to leverage what we've learned uh, in maybe it's not even intermediate, maybe it's just beginning algebra. What we're going to say is, hey, you know what? If I have a straight line, I know the formula for the straight line. It's y equals mx plus b, where y is the total cost. And in this example, m is the volume, right? Fuck. M is the volume. How many units am I going to produce? X X is my variable cost for every additional unit I produce. What is going to be my incremental cost? So the M, the volume of units, times X, the variable cost. And then I'm going to add all of my fixed costs, B, the y-intercept. Okay. So what we're going to do is we're going to try to figure out if I know my costs for a particular year, and then I know that the equation for a straight line is at least y equals mx plus b, how can I go about using all of this information to estimate what my costs are going to be? And that's what we're trying to get at in these slides. So in this particular approach, or at this particular slide, we're basically saying, look, there's going to be three methods that we're going to use, right? Down here, down here is our data. Okay, so what we're saying is here are all the units that we're producing. We're producing 30,000 in January, 52,500 in February, so forth. And then our associated total cost is the next column over. 23,500, 28,500, etc., etc. So I have 12 months of information here. I have the same data for January through July. And now I think what we want to know is, with this information, can I estimate a particular total cost for a month next year if I know how many units I'm going to produce in that particular month next year? And the way that we can use these data to try to estimate what our total costs are going to be under various situations, we have three methods available to us, okay? We can use the scatter diagram, and I'll do that in a second. Then we could use the high-low method, which is what we're going to spend most of our time in this lecture talking about. Or we could use something more sophisticated called regression analysis. But these are the three methods that we're going to use to try to use the data given to us to estimate costs. All right, so the first one is a scatter graph. And what we're saying is we're taking these data from this schedule. And so we could just simply start with January. January, 27,500, right? So I have 27,500 in January. That is probably this data point right here. 27,500. Maybe it's this data point, actually. That probably seems like it's 27,500. So what we're doing is we are taking all of the data, the volume in a particular month, and the associated total cost, and we're just going to plot it out. Then once we are finished plotting everything out, then we can draw a line through it. And that's what the orange line is. This is the scatter graph approach. It's kind of an eyeball test, and it's not the most sophisticated approach. I would say that we rarely use this in real life. It's interesting, but it's not something that we typically use. What we will typically use is a slightly more sophisticated. It's still very archaic in some sense, but it at least is easy to understand. It's the high-low method. It's the second approach. Okay, so the high-low method. So the high-low method, what we're going to do is I'm going to go back to my drawing and I'm just going to erase everything. In our high-low method, what we're going to do is we're going to take from the data that we're looking at, we are going to take the high data point and the low data point. And the high data point is going to be with respect to volume. And the low data point is also with respect to volume. So what I want to do is go back to my data and I want to say, okay, what is the fewest number of units that I produced in one particular month? And I believe the fewest units I produced in one particular month looks to be June, right? So I have 17,500 units produced. That appears to be the lowest. And then in addition, what is the highest? What's the highest data point? And I think from all of the data given to us, it's looking like November is the high data point where we have 67,500. So I'm going to go back to my drawing and I'm going to say, look, here is the low data point. Here is the high data point. And the associated volume with the low data point, I believe, was 17,500. Yes. Sorry for making this crazy, but it's 17,500. And then the big data point, 67,500. And then the associated cost, I'm going to just do up above. The associated cost, 18,500. 18,500. And I'm just going to put dollar signs there. And then I am going to take the high cost, which was, hey, 31,000. Interesting. Now I could use the high-low method. The high-low method has a few steps. The first step is we want to figure out what the slope is. All right. So again, if we have y equals mx plus b, the first variable we're going to try to figure out is the slope, the m. And I can do that with these two data points. In our algebra class, I think we were saying the slope is going to be um, rise over run. And in that particular instance, I think I can sketch out my rise. I'm going to go the high first, and rise is on the cost side. So I'm going to take 31,000 minus the low data point of rise, which is 18,500. And then I'm going to do the run. The high data point on the volume side or the run side, right? Again, this is the run, the volume. It's going to be 67,500. And the low, 17,500. Now I'm going to do all of this in not my head with my calculator. So while I'm finding my calculator, I'm going to pause this so I don't. Okay, I'm back. You guys will love me since I didn't waste your time, but I did the math for us. Our rise over run, the first step was 12,500. So if I took 31,000 minus 18,500, I got 12,500. Then if I took 67,500 minus 17,500, you are correct. I can't do that in my head. I got 50,000. Then I did 12,500 divided by 50,000, and I come up with 25 cents. So what we are now saying is that for every additional unit that we produce, it is going to cost us an extra 25 cents. This is clearly step one when we are using the high-low method. Now, what I can do is I can take the results from this and I can plug it into one of the data points to try to figure out what my B is. So the second step, maybe I'll do that. Maybe I'll just do it right here. Second step is that, look, I now know that if I produce 17,500 units, it's going to cost me 18,500. And I also know the incremental or the variable cost, which is 25 cents from step one. I can now take all of that information and figure out what my fixed costs are. So let's do that. All right. So Y, that's going to be the 18,500 from my low data point. 18,500 equals 17,500 units times 25 cents per unit plus my fixed costs. Then I can do this algebra. Hopefully it's somewhat on the simple side, but I can do this and solve for B. And I won't bore you with. I did the calculations for us. 17,500 times 25 cents. And then we subtract that from both sides. And so we ultimately get that our fixed costs are 14,125. And now I know I have the formula to estimate costs. My formula is now Y equals 25 cents per unit times X plus 14,125. I love it. I'm going to go back to the slides. I'm going to go through the slides and hopefully I didn't make any mistakes, but let's see what the slides are telling us. Okay, they identified the same 2 months. They identified June as being the low volume and November being the high. So far I'm doing okay. Then their step one was let's do the high low, the cost of the high minus the cost of the low in terms of volume. Sorry, in terms of cost. And then they did volume and volume on the bottom. So they said, yeah, their rate per additional unit is 25 cents. Same result. Then they plugged their 25 cent. Actually, did they do it in the same one? Hey, they plugged theirs into, they also plugged it into the June data point. I kind of like the idea that we pick the data point closest to our fixed cost. It just seems to make sense. But we could have just as easily, we could have plugged it into June or November. We could not plug it into any of the other months, and I'll get to that in a second. But they got their fixed costs as being 14,125. So the total cost is $14,125 in fixed costs plus 25 cents for every unit produced. Awesome stuff. Really cool. So let's just say that I don't know, let's say that we produce or we want to produce, we're going to produce 70,000 units in some month next year. How much is that going to cost? Well, it would be 14,125 plus 25 cents per unit times 70,000 units. And if I were to do that math, I come up with 31,625. And boy, it seems like that's probably kind of close to this, right? So 67,500, I've got 31,000 in costs. So 70,000 units, it's going to be slightly more than 31,000. And what we're saying here, or what I'm saying is, yeah, if I produce 70,000 units, I could expect to incur $31,625. Regression. Regression is a more sophisticated approach to estimating costs. If I go back, actually, you know what? We're not even going to use a regression in this class, but if you were to use regression, what we would be saying is that based on the results, our fixed costs would have been 16,688, and the variable cost per unit would be 20. So I think our high-low method is coming up with this approach, and then the regression analysis is coming up with something with a higher fixed cost and a slightly lower variable cost. Which one is more accurate? In all fairness, the regression analysis is probably going to be more accurate if we have more data. You usually need about 12, but I would say between 15 and 20 data points in order for you to realistically use regression. However, using high-low is still okay. And the reason why we're coming up with two different numbers or two different formulas is because if we go back and look at the scatter graph, some of the data points are not on the line, right? So the high-low method is going to pick one data point on the line and another data point on the line. And unfortunately, there are instances where we don't have data points that are on the line. And therefore, what we're saying is our estimate is probably not 100% accurate. All right. So I could have a bunch of data points and I can do my high-low method. I would take this data point and I would map it to that data point. That's my high-low method. And then the regression would be something more like this. And the question is, if I have an instance where I'm producing this many units, what can I anticipate? Well, if I use regression, it's going to be one amount. And if I use high-low, it's going to be a slightly different. Unfortunately, we don't know with certainty what it's going to be because things change and fluctuate. However, we're just trying to estimate. And based on our estimations, the high-low method, at least for this course, is the most reasonable one to use.